Hi, everyone. Good morning, good evening, and good afternoon from whichever part of the world you're joining from. Welcome to the 2021 events of Brazil's Women in Data Science. Women in Data Science started as a one-day technical conference at Stanford in November of 2015. It now is a conference with 150 plus regional events worldwide in more than 60 countries, reaching 100,000 participants annually. They also have datathons, podcast series, education outreach programs, and workshop series to build your data science skills, inspiring women and girls with role model instructors. Women in Data Science Conference of 2021 comprised of 2,000 plus attendees from over 65 countries. There were 200 plus events and 40 plus speakers, and overall involved 100,000 participants online. In Brazil, the Women in Data Science chapter is led by the ambassadors Maya and Arti. And there are 8 talks that were lined up from amazing speakers for the month of March. We also have the community partners as D5. So here we can see the number of events that were organized this year in the month of March and April. And we're already at the second last event for the list of events, which is today, 30th of March, Recommender System, a boon for both worlds. The speaker for today's session is Sukanya. She's passionate about turning ideas into data products. She enjoys building and developing high performance teams, mentoring data science enthusiasts, and working in cross functional teams. She has an extensive experience in retail, FMCG, insurance, and shipping industry with multiple algorithms patented. She is a Women in Data Science ambassador for Dubai, and she's also been a mentor for participants for Women in Data Science Datathon in Kaggle. So, Sukanya, the stage is all yours now.
Thank you. Thank you, Ganika. Good day, everyone. Thank you, Brusel's data science team and DFI for inviting me to share my learnings with the wider community. So as all of you would know that I would be presenting today on recommender systems, and I will try to balance my entire presentation to adhere to all level of audiences. So let's get started on the recommendation systems, and I'll quickly share my screen. Okay. Yeah, sorry for the hiccup.
I'm Carlos Gomez Uribe.
Okay. I work. Just give us a minute. We were testing this out. Okay, here we go. So, okay, so great. So coming to the recommender systems, right? The purpose of a recommender system in simple terms is to suggest relevant items to the user. So we might find very fascinating definitions across in the internet, but mainly dependent on the user. It can be an internal to a particular industry or an external facing the customer, right? So today's session, I would be dividing it into 4 parts, basically. One, we would be talking about the business value and the overview about what is the recommender system all about, what are the KPIs that we look forward to, and how does it really gonna benefit us, even if we want to invest our time or better down the algorithm that's already existing in the industry. Second, we will be taking some case-based reasoning. Does one size fits all? So we will be taking few examples that's running in the industry presently today. The third part, I will walk you through some of the pricing recommendation engine, something that is scarcely getting used across industries and is just ramping up with time, something that I'm actively involved with. And the fourth, we're going to talk about some future work on how do we see these recommender systems in a decade. So to then get started with the business value, right? I've taken up a few benefits out here, not that it covers entire 360-degree, but to just look into a few points here, right? How did recommender system started? What are the benefits that the companies started feeling to drive their revenue up? And some of the factors here are, as you see, to drive more traffic or more customers to their particular platform, right? Online platforms, or to deliver a relevant content. So many of us today who goes and reads a particular content, like a news app or a particular channel that we follow, we or a Facebook feed, so as to say, right, or a news feed, everything we look for our relevant content on the things that we are interested in. So more and more companies are adapting this. Also, we have seen a wide audience and customers and end users on the retail front. So to engage shoppers at all various levels, categories, and deep down now, it's dynamically exhausting the number of variables that we are using for recommendation engines, right? Uh, Next, being converting a visitor to customer, it has been always that sometimes we just try out some particular app, a site, and just we go to check it out, like for window shopping. But somehow some of the apps in today's world captures and like pleases us to a certain extent, that of course we entered as a visitor, but we end up buying something because of the value that it provides, or the experience that it provides, right? We also prefer some of the apps than the other apps, or we sometimes also get irritated with some of the search engines that's out there in the app, or the recommendation system that's out there in the app, and then we just hop onto another app. um, this is something that we all experience on our day-to-day life. Also, you would have also increased that you went to buy something, that you you had a budget around $1,000, but you ended up buying something of $2,000. So of course these recommendation engines are influencing to the order value, giving more revenue to the company and increasing the number of items per order. So this is something that has started long back, and now running in a more proficient version, so as to say, in the industry, where we keep getting more and more options around what are the number of items per order that's out there. If the customer is buying some similar items, which is on a quantity of 3, then how can we push for 5 quantity at the price of 3? And we all come across these kind of offers combined with marketing and recommendation that's out there. And some of the deals really works out for us, right? So of course these are some of the KPIs that the companies are tapping into, and the control inventory rules that's out there. So also we have observed that as a customer, some of the item that we want to purchase is capped onto some particular number. So for example, you want to buy a health drink of like a 2-liter bottle, and you see that it's capped to only 4 quantities that you can order at once. This gives a better control not only to the seller but also to the user, whether they want to really take Captain 4, or they want to go for a different seller. So you would also see that I'm not stating that entire session as a recommender system that's only going to generate a lot of revenue for the companies, right? But we are seeing a lot of boon to the customer front also, reducing our time on the screen for search on anything, or giving us relevant content whenever we are out there in the world searching for something. Now, apart from these benefits, right, if we also look into the challenges while building the recommender system, now there are a lot of challenges technically. If we deep dive onto the algorithm, what are the pros and cons of each of the algorithms that we are driving, or the core crux, and that is the main engine behind it. But just if we zoom out a little bit, what are the key challenges that we really face? Mostly that has been around these 4 factors. Given my experience in the in several industries, also my colleagues, what I've heard about, and also what I've heard on the wider audience. So mostly it's one being on the data. So of course we all know that it's not only for the recommendation engine, but even if we want to go for any kind of machine learning or predictive analytics, data is the key element, right? And they generate accurate recommendation based on the available information. So it only makes sense that the recommender system thought to be the best ones are those from companies who are in possession of vast amount of data. So we see excellent recommender systems from Google, we see good recommendation system from Amazon, Netflix, YouTube. These guys are like sitting on abundance of data. And of course, the better the data we have, the better the recommender system analyzes the data or the customer behavior for a particular section, and find similarities and suggest items, right? And we can also build AI on top of it. So data is the crux, and some of the industries are still struggling to get the data. Now, second being the people. Now, why do I emphasize on the people? Because people are our end users, right? And also, to be honest, a source of large share of the problem with recommender systems. So they may be unpredictable. So I can remove the word maybe here, because people are sometimes unpredictable, right? They might just look for some fiction, kind of a movie, but it does not really mean that they are not interested in a comedy movie, right? So sometimes this is where the factor of recommendation systems, we need to add a discovery element, so as to say, because this is something that we need to factor in, where people sometimes don't know what do they want. And sometimes it might not be a very similar item, very similar content, but still we take that risk, a percentage of buffer, to just check it out with that particular user, whether they are really liking it, whether the click stream is working for them, or how are things around it. And the third being the changes. So changes is something which is every day, so as to say, right? So data is changing, our preference, user preferences are changing, the business is changing all the time, we are changing our KPIs, we are changing what are the things that we want to target. So a whole lot of updates, and these algorithms need to keep up with the changes. Whatever we design today needs to be relevant 1 year later, or maybe 5 years later. So that is also a key factor, I would say, is a lot of challenge, because something, a key variable which would have worked 5 years back, is no more relevant in today's world. And of course, the fourth point being on the optimization. So this particular optimization phase, I mean, has been used across industries, and it's a very hyped word, so as to say, because every recommender system that is built, we just want to get better and better over the time, right? And like, of course, machine learning algorithms help the system learn the pattern, but the system still needs some guidance to provide relevant results, and that needs to be very relevant with the changing business that's out there. So how do we improve it, or make sure whatever changes are introduced, like, we are still going towards our business objectives, right? But also here, I would like to mention a couple of points, which is mostly around Netflix. So let's look into the Netflix annual revenue, right? And when we look into Netflix annual revenue here, like, they have constantly been improving their recommendation engine, and they've invested a lot of money and time. But I think it pays off, because recommendation influences almost 80% of the content watched on Netflix, right? And this kind of algorithms that they are developing is contributing to lower churn and helping them to save billions of dollars. So of course, there's a lot of value, though there are a lot of challenges, there's a lot of value in these recommender systems. And also helping them for customer retention, and also new customers are signing up. So like, Netflix is mastering the art of recommending as fast as possible. So even as a user perspective, if I can think here with an open mind, any of us, when we tap onto Netflix, we browse for 90 seconds, 10 to 30 slides or genres, so as to say, like titles, and then we get exhausted, right? If the recommendation is not working pretty well, but still we see that the Netflix algorithm is trying to give us better recommendation again and again. And that's where, if you see this particular graph, right, they have almost grown 6 times more, from $1,000 revenue in millions in US dollar to 6.7 now. So of course, recommendation system is something, is of great value, and we need to consistently learn about it, grow about it, and improve on the AI, and it's definitely worth the investment. Also, if we quickly look into the Amazon, right? Amazon is something like, if they are like what can I say, the word, like undoubtedly the king of online retail, so as to say, starting today, right? And the company introduced their item to item collaborative filtering, which we're going to touch base in a couple of minutes to give more context about what is it, as early as 1998. So they have been improving the recommendation ever since. So the earlier adopters, and if we look into their graph here, right, with annual net revenue of like business to customer itself, they have grown massively. So Amazon has never really revealed how much revenue is generated to because of their recommendation engines, but roughly from the other outsourced companies who moderately aims to look into what is the percentage of their revenue can get affected, and with all the data that's out there in the Statistica, we know that it's almost affects 35%. So that's quite some revenue from the recommendation engine. Next, there is a case-based reasoning. So does one size fits all? So before I would have hit into this case-based reasoning, I would have liked to do a quite quick poll with all the users, whoever is checking this particular session right now. If you can just go into menti.com and use this particular code, you would get uh, like a like once you land onto menti.com, you would just be asked for this code, and that is 74248780. And if you can just file in your inputs about what is your awareness standing today when you're watching the session about the recommender system. So is it initial? So this is something that I'm talking about from a 360-degree view, not only on the algorithm building, but a complete awareness about the recommender system. So initial, or you are an initial algorithm starter, or a mid, or an advanced. So this is something that we can look later on the votes that has come through. But then to get started, right, on few types of recommendation that we can touch upon, and that's where I mean, if we note standing today, there is like we just look into three key factors and the most important recommendation engines, which are like the collaborative filtering, the content based, or the hybrid filtering. But here I have also included a couple of more, like the demographic based filtering, utility based filtering, content based filtering is something that we touched upon, and knowledge based filtering. And hereof we have a lot of other factors which we used, and algorithms that we used in our recommendation system building, right? So for example, if we want to look into the user based filtering, right? So this picture, what does it depict to us? So basically what we are trying to do is, this is called a user collaborative filtering. So we are just trying to search for lookalike customers that offer product based on what his or her lookalike has chosen. So if you see here, Tim, whatever the products he has chosen, since two of them tally with Tim, so John is being recommended the other products which Tim has tried. So this is very simple, but works extremely effective. So this is user-based filtering, so as to say. This is very effective and takes a lot of time and resource to be built. And this type of filtering requires computing every customer pair information, which also takes time. So for big base platforms, this algorithm is hard to put in place. Next, if we also look into another kind, right, item based filtering. So here, as we clearly see, right, it is very similar to the previous algorithm, but instead of finding a customer lookalike, we are trying to find the item lookalike. So for example, here, whatever Tim has taken up, so we are just looking into the item being bought by a particular consumer, and then John has selected one of those particular items. So since we have a set of items which has been selected, we suggest that the first ice cream is something that John might like, right? Or be it another item, maybe the last donut, which he might like. So this is more on the item-based filtering. And once we have the item lookalike matrix, we can easily recommend alike items to a customer who has purchased any item from the store. So this algorithm requires far fewer resources than user-user collaborative filtering. Hence, for a new customer, the algorithm takes far lesser time than the user-user collaborative, as we don't need any similarity scores between customers. So to build the similarity scores also, we need to develop the data. And also, this is some of like this approach is especially used in Amazon and its product recommendation engine to show related products, which like really boosts the sales. Next, we can talk about a little bit on the content-based filtering, right? So content-based filtering methods are nothing but like you have a description of an item and a profile of the user's preferred choices. So in a content based recommendation system, keywords are used to describe the item. So the items will be having a particular maybe a text of description if it's a retail, right? How do we really break it up and get more factors out of that particular keywords? Or a user profile is built to state the type of item this user particular like. So in other words, this algorithm try to recommend products which is similar to the ones that a user has liked in the past. So it vastly uses the data that's there in historically. And the idea of content based filtering is that if you like an item, you will also like a similar item. So this is something which is heavily tested across industries and platform today. So but it's also rooted into the retrieval and information and filtering research, right? So it's a really time consuming compared to a user-based filtering. And similarly, demographic-based filtering. So of course, what are the kind of FMCG products that get influenced? So it might just vary. If you are in an area like San Francisco to a place where you are in New York, or a place in Africa, or an entire country like China, right? So demographics play a critical role. The same kind of items that's getting sold, that gets influenced. Some of the areas have their own recommendation, their own preferred brand, their own sense of pricing based on the competition pricing as well, right? And also utility based filtering. So utility based filtering recommendation can come through from how you are using a particular app, or how you are using a particular application, so as to say, be it on your web or your mobile. uh, what are the tabs that you're interested in? What is that you're searching? What is that you're purchasing? Or what is the engagement that you're having? So it just gives you a recommendation based on that, notification based on that. And then there are knowledge based filtering, where there is a lot of assumptions in place, and all the hybrids of these kind of filtering are getting used, like the utility, the demographics, and together. And the last but not the least, and the easiest of all, which most of the enthusiasts wants to try their hands first on, is hybrid filtering, right? So hybrid filtering is nothing but a combination of collaborative content-based recommendation, which can be more effective. So it's implemented by making content-based and collaborative-based prediction separately and then combining them. So it's like a unifying approaches onto one model. So basically, I believe you guys would have got an idea about the types of recommendation. I do not want to dive more deeper, but what I have done is this PPT is something that will get shared, of course, in a folder, I believe, with everyone on the audience. But there, this is where I have linked a lot of factors which you might want to give a hands-on try. If you are an initial learner or a mid learner or an expert, to know what's going on, and to learn more on how do we really design and what are the other things that everyone is trying out, right? So here I have also provided a GitHub link that is going to help you to get some codes to drive the recommendation algorithm. This slide, I want to focus a little bit on choosing the right recommendation algorithm, right? And this is not something that we go by die hard, like we really do not want to follow it like a Bible, but this is like a super quick kind of a route that we want to have it in our mind, right? And what is that? So if you just look in here, So you need a super quick solution. This is what I was talking about. Most of us just jump onto hybrid recommenders. If not, and if you're planning to build a very systematic recommended system, then we do a little bit deep dive on the data set and usable features that's out there. So that literally takes away 80% of your job time. But if at all we figure out that there are usable features, then we go ahead and look into the rows that we are dealing with, the number of years of data, the backend historical data that we are dealing with. And if it is greater than 1 million rows, then we go for content based filtering, because of course there are going to be a lot of usable features. There's a lot of data, and of course we can better recommend through it. And if like it's not, then we can go for a graph modeling, which is like fairly easy and quick to get into some kind of recommendation that we are looking for. Either way, if we do not have some usable feature, and then we just jump onto the number of millions of rows, and if it is greater than 1 million row, then we of course go for collaborative filtering. And if it is not, and then we also ask a question about the frequently onboarding new users, right? Which we were talking about, that it's critically important to understand, because on a user based collaborative filtering, you will not really, the model will really take a lot of time to really build and recommend something. But for example, if you're a new user, what are the top 10 movies that's going to get recommended to you? Or if you're a new user on a particular platform to buy flight tickets, for example, and you have 3-4 brands out there. So how do we really influence you to get the right flight? So similarly, we take up more or dimensionality reductions and so on and so forth to get more value out of the data that's out there. Next is something that I would like to play a few minutes video out here from Netflix. And I would really request you guys to listen to this carefully, because to be honest, to understand recommender systems, we really need to just learn a lot from what these companies have been testing and trying for a very, very long time, right? And this is going to help us make a lot of breakthrough, given that we are now trying recommendation not only for B2C, but also B2B internally, as well as a lot of decision support internally without even affecting the customer, and across multiple industries, even healthcare into picture. So I'll pause here for a minute, not speak much, but I'll just play the video. And let's just watch this quick guide from Netflix.
Hi, I'm Carlos Gomez Uribe. I work on our personalization technology here at Netflix. You may not realize it, but every TV show and movie recommendation you see on Netflix is a highly personalized suggestion just for you. The goal of our recommendation technology is to make it really easy for you to find something you will love to watch. Our recommendations work very well. About 70% of everything Netflix members watch is a personalized recommendation. Recommendations start immediately when you join Netflix. Initially, recommendations are personalized based on your answers to a simple taste survey. If you told us you love comedies and horror, we might recommend scary comedies. But this is only the starting point. Our recommendations get fine-tuned as you use Netflix. That's how we get to know you better. Our personalization technology is based on a set of techniques that are always learning more about the movies and TV shows you like to watch. In addition to analyzing what you watch, we also look at what others watch to come up with the best recommendations for you. Our recommendation engine even creates highly specific genres for you. Personalized genres are generated using thousands of movie and TV show characteristics, including actors, storylines, characters, and time periods. We also give you personalized top 10 recommendations to make it even simpler to find something great to watch. There are also rows of recommendations based on specific shows you've watched. If you haven't noticed Netflix personalization in action, compare your Netflix to a friend's, and you'll see how unique your tastes actually are.
So we got a sneak peek, right? That how Netflix really uses their recommendation engine. So from what he spoke about, it's a little high level that we are looking at. He is more on the personalized recommendation section, which definitely requires a hybrid recommender system. Now, the website makes recommendation by comparing the watching and the searching habits of similar users, which is like a collaborative filtering, as well as by offering movies that will share characteristics with films that a user has rated highly. So, a content based filtering, so as to say. So, overall, if we really try, right, what he talked about, that if you just compare on even inside Netflix, the different users that's there, we definitely see that the recommendations are different. Given how we know now that how the algorithm works and what are the variables that keeps into picture. Now, let's also look into Amazon. So these guys are pioneer and have started using collaborative filtering on in the year of 1998, right? So let's hear from them. What are they speaking about? What have their learning been so far?
The very first recommendation engine that we built using collaborative filtering was considered revolutionary 20 years ago. It was an early version of a machine learning algorithm. That recommendation engine helps customers discover related items, like a camera bag or the lens for a camera that a customer had just purchased. It's still on the site, and it's still a huge help for customers. When we later combined collaborative filtering with heuristics to make recommendations, we were able to give customers personalized recommendations rather than just showing them popular items. Fast forward a few years. Add in the exponential growth of computing power provided by Amazon Web Services, plus the improvement of sophisticated machine learning algorithms. And we start to get dramatically better results, on the order of 2 times better than a typical algorithmic improvement. That's a once-in-a-decade leap. That helps us to personalize our content and recommend goods that a customer would like to buy and movies that a customer is more likely to watch. Let me explain how we achieved these goals. And it wasn't a straight line to realize the improvements. In 2012, we wanted to update our product recommendation algorithm to improve personalization for customers. We started from state-of-the-art graph clustering techniques. Then we shifted our approach under the hypothesis that deep learning methods would outperform matrix completion methods because we could take advantage of nonlinearities. But we found this approach performed worse than not only our best collaborative filtering algorithm, but just a simple bestseller, a ranked list. Then we used a common artificial neural network called the sparse autoencoder. But it was still not as effective as collaborative filtering or the bestseller list. In fact, we tried methods based on singular value decomposition, bilinear regression, and restricted Boltzmann machines. Nope. None of these matrix completion-based methods underperformed or overperformed compared to our production algorithms and simple lists. We were surprised that the state-of-the-art methods would perform worse than a simple bestseller list. So it prompted us to take a step back and think about the objective function that we were trying to solve. We looked inside the black box to identify what was happening. I'm going to explain this in the context of Prime Video, but the same approach applies to many products on Amazon. We found that matrix completion methods learned that classic or Oscar-winning movies would be of interest to many customers. Makes sense. However, we saw that given an evening at home on a rainy Saturday, customers prefer to watch a newly released movie rather than an old movie. In other words, Captain Marvel beats Casablanca. This learning became the foundation of our winning approach. We developed a new model for recommendations using multi-layer neural networks for classification. We trained the model using a loss function for predicting what customers wanted to watch in the next week. What you see on the screen is the formulation behind the model. We took historical movies that customers were watching in order to predict the movie a customer wanted to watch next week. The neural network classifier outperformed other neural network-based approaches that are much more complicated. The simplicity of this model made it inherently more scalable, so we could expand to many millions of products and hundreds of categories across Amazon. And it performed 2 times better than collaborative filtering, so we had a winner.
Right. So as you also heard from him, right, is something that I echo the words completely. Some of the hands-on experiences on trying to turn the non-linear variables that's out there has been a complete mess in the past. And in many industry, we have failed to really get values out of it. And some of the deep learning methods also did not work. So even in my experience, the collaborative filtering worked like at a different level altogether, the kind of accuracy that they were giving. And also another point that I would highlight, what we just heard here, if you have observed that they are trying to predict now that what a customer might watch next Friday or what a customer might buy. So this is no more a silo, so as to say, on the recommendation front, but it is something with the prediction front, it is something with the support decision factor, it is something with the real time clicks that's happening with the customer. So it is going now in this particular world, and in the next decade it is going to a different level altogether, and we are no more talking about recommender system in silos, right? Not only about collaborative filtering, not only about hybrid filtering, not only about this deep neural networks. So there are like various forms that's getting used before coming into the recommendation section, right? Like they're using the k-nearest algorithm, Jaccard's coefficient, cosine similarity, all the things that is there to better relate the data sets of people for recommending based on the rating or the product that's out there. Now, Netflix and Amazon, of course, have been the pioneer in setting the aura for recommendation system. But let's also quickly look into a very small video about recommendation system. Like how do we get the personalized news and feeds? So many can call it just that, this is something, a different sections altogether, but personalization is getting into the key crux, so as to say, if we do not find our personalized food, if we step into Zomato, or we do not find a personalized a movie recommendation when we step into Netflix, I think that is the kind of world that everybody is craving towards, and many of are unhappy if we have some better experience in the past, right? And then let's just quickly look into what Mei Hong Wong has to say from Facebook about personalized news feed, and how Facebook is dealing with the massive amount of data that they have, and how are they recommending and providing us personalized feeds.
So the first question we have to answer is, how do we define the relevancy? So this is very subjective, and every people have very different opinions, and that's where the personalization comes in. So the major approach we take is to use the user feedback on the story to approximate the relevancy to the user. So for example, user can take all the actions, a like, and share, a love, and a comment on the story. So those are really, really strong signal indicating people want to see the content, they enjoy the content. While other actions people can take on a story is like, you can hide the story, you don't want to see the content. So this is really strong negative signal to indicate that people don't want to see the content. With all the historical data we have, basically we can learn a ML model to predict for new story, how likely users are going to take all those action on those story, positive ones or versus negative one. So here is one example with our prediction model. So with this particular story and the user pair, we predict all the probabilities. For example, there's 11% chance people will click, user A will click on the story, and 2.2% chance user A will like the story, and also around 0.1% of chance people will hide the story. So we weighted the score together and get the final ranking score. For this example, the ranking score is 0.2 2277. So for user A, when he loads news feed, and we basically rank all those content and rank the content based on the total score here. One important note here is all the probability column, these are calculated with machine learning models, and this has the ground truth and very personalized, while the value column is more of like subjective and based on the user study and the product decision we make. So for example, on Facebook, and the value for user is more on the interaction with people. So the like and the comments are more meaningful to user than just clicking on the story. The weights of a like or comment is much higher here. The weights and the probability here is just an example to demonstrate the points here. So here are the more detail on the prediction model. For ML model, the feature and the labels are the most important two parts. So when we have the feature joiner system to generate a lot of training data for us to train the model. So when the user load the news feed and we do the aggregator does the ranking and the return story back to the mobile. At the same time, the feature will be logged to the feature joiner. And the same with the user's feedback events, like a comment, they also be sent to the feature joiner. Then the joiner basically generates a training data with the feature and also its a label. Those data will be fed into our model training service, and the model will pick up the weights and retrain the model and updates the weights to our system, and the aggregator will pick up. For our model, we have a huge model, and typically the training example size around billions of examples.
Okay, so we have heard that excellent note, right? They are sitting on top of billions of data. And how are they actually leveraging things out if we really look into Facebook, right? Especially here, if on the personalized feed with billions of users across the world, it's a pretty massive computational intensive. But what we observe is they are going about it in a very different format where they are creating their own events, where we are just not looking into a particular click stream or something, but a reaction to a particular post, right? Putting values to it, and also using the ranking system, which is working with flying colors even for Amazon. So the key learnings that we had from these three massive players in the industry today, of course these are the algorithms that we should be trying our hands on, and of course there are some of the industries where we need to try our hands on to deep learning, and we have to keep the research going until we get another breakthrough. And also, as we heard from Amazon, that I mean, neural network recommendation algorithm is a breakthrough that they came through over a decade, right? So we never know what works out for us well. With that, I would like to step into a third section, and that is on pricing recommendation engine. And here I would like to talk about a little bit first on dynamic pricing systems and recommendation engine. So though they sound a little bit similar, but they might not have a lot much in common, right? So dynamic pricing, so as to say that it's meant for targeted pricing optimization, be it for a retailer or be it for any industries. You would have all, like, just to get started off and give you a simple idea before we get started with this conversation around all the technicalities, right? That you would have experienced something with Uber. If it starts raining, the rates just go up twice. And how are they coming up with that particular dynamic pricing? Or if a big extended holidays is coming up, Airbnb for a certain particular destination, vacation location, the rates of the rooms are just going up. Or you booking a flight 2 months away to your experience booking a flight maybe 1 month away from your departure date or 7 days away from a departure date varies a lot. So that is something that we are talking about, dynamic pricing. And then what is this pricing recommendation engine is also that we are trying to talk about. So just to give you guys a quick overview, right? So this is something that both these graphs have picked up from the internet, and you would easily see the reason I've picked it up because it gives you a clear visual. So maybe a static pricing in place earlier when we had Uber, we know from A to B location, this is the standard price that we pay, maybe $200, right? But with dynamic pricing, what is that we are unveiling? in the industry in a real time. Of course, they generate added value from data, and it's focusing on the customers' needs. And also helping the company to optimize. For example, if you're talking about Uber here, right, the number of cars that's out there in that particular location or vicinity, or the focal point that they want to keep it as a parameter. So a person who is just standing 500-meter away from me might have a completely different experience with the same Uber booking in the same direction than what I am having. So typically, this is something that is becoming more and more relevant, and it's also becoming more successful on the retail industry. So, for example, the kind of product prices that a particular user A is getting showed might be very different from another user in the same house. So of course, we are seeing a great impact of the recommendation system, and but also I would like to emphasize the great benefit that we generate, right, quite incidentally. So we gain deeper understanding of our customers' interaction with the product. So which items are very high in demand, which items they really want to buy frequently, or what is the rotation that they want an Uber frequently, or you would also see in retail there are something that we end up in the shopping basket but we ultimately don't buy it, right? So these are the information that we can really use to influence a particular customer, the kind of rate that works out for them, and also for the company to make a little bit more revenue, or optimize their entire network to make more cars available where the demand is going to cross high, right? So it helps to optimize inventory levels. It helps to make price decision, which is like dependent on most important indicators from the customers. And also we can build AI on top of it. So here are like in the right hand side graphs, if you also observe, right, there are like certain commodities which it shows like with competition how they are performing. So all the greens, how we really going up given our prices in place. So the same FMCG product or a particular product that we are selling from multiple sellers in a seller platform, and vice versa, right? So be it a comparison within in airline industry. So I've put a link here on the Kaggle where you have a good data set, and also a good comment sections and a forum going on how do we really understand and set up a recommendation pricing for a retail customer, right? Which is quite different to what I'm going to talk about hereafter. So dynamic pricing is something I want to touch upon before going on to the recommendation engine part, where how is it that is different? So dynamic pricing is it like key factors which can influence the types that we are looking at, right? So peak pricing is something that we talked about, where given external XYZ factors, it's affecting the supply demand basically, or be it it's a supply demand basically on the locality that we are in. And then of course there are competition prices up there. There are segmented dynamic pricing if there are different categories of products that we are looking into, different kinds of cars that we want to hire for a destination A to B, right? Or a particular customer behavior on the content based filtering. What are the things, or where have the customer visited, or what are the customers have bought earlier, what is the frequency of the customer coming back to the app, or for a particular service to a particular company, and the loyalties, or having more value based attached to it, right? And also time based dynamic pricing. So maybe there is a accident which has happened, or there is a traffic jam because of XYZ reason, and that is something that is causing a lot of dynamic pricing in Uber or a particular area compared to others, right? And these are the factors that helps us to serve customer better. These are the factors which helps us to identify where things are breaking and to make the algorithms better, and more learnable about the customer contents. Next here, me being typically from the shipping industry, right? So I've put here what do we really call it as an inventory. So inventory might just be very different. When we talk about optimizing inventory, it's basically holding up to the supply and demand that's out there in the market. And this is something that is critically important, be it for a hard rock store that's out there like Target, also having their online platforms, or be it for companies like Amazon, who are 90%, 95% plus operating completely on online, right? And also for airline industry, be it or for hotel industry or for shipping industry, inventory is critical. So for example, why I have shared this particular picture with you guys, because if this particular ship is calling for a week and the routing is fixed for this particular ship, we cannot extend the capacity of this vessel by any chance. So it cannot extend 5% extra. We cannot deploy vessels just like Uber if they want to deploy more cars around a local area where the demand is getting higher. That really does not happen. And same goes with the airline industry. And that's where it is extremely critical on how do we do dynamic pricing or build up a pricing recommendation engine, because here customers starts booking a 1 month earlier, where various customers have different kind of characteristics in place. So some of them are looking for lower rates, and how do we really price about it? So do we start really low or do we start really high till the ship sails? And if we start really low, what are the kind of customers that's booking with us, and what is the amount of volume that they are getting to us, right? Yeah, or what are the container type that we are opening? So there are different kind of container type, like a 20-footer container, 40-footer container, reefers, or be it a hazardous cargo, or be it a special cargo. How much is the percentage that we are trying to give them space on our ship? So the pricing of these different various types of categories, quantities that's out there, just like a retail online shop can do easily bend their rule. These are hardcore industries where we really need to be a foot front on how do we really design a price recommendation engine, or how do we really build a decision support engine for people who are doing dynamic pricing on the go. So it is critically also important to have sales data, transaction data. Market feedback is important. What is going around the ground? There are so many festivals which affects cargo movement. Recently we had a week back, we talked so much about the Suez Canal, right? It literally was a heavy pressure, so much of traffic building up on the sea, and millions of dollars at stake. So it's extremely important what are the factors, to identify what are the factors that really influence, and how do we really price to make it more customer oriented, to understand the customer needs. For example, a customer who is looking forward to ship commodity rice is not in a best position to pay a great buffer compared to a customer maybe who is trying to ship oil, right? Or be it a customer who is on seasonal fruits and sending through reefers, or through meat, meat that comes in containers, and there are different various factors that influence, or be it tiles, which are really heavy cargo. So there are different kind of customers whom we need to do different kind of pricing, and how do we really develop a particular pricing recommendation engine that can really affect or build a dynamic pricing system or decision support system in parallel to really move things, because this is nowhere we are trying to influence a particular customer purchase here and now, but also to a larger extent, right? Like we are opening the ship 4 to 6 weeks out. Now connecting price to value, right? It's of course a methodology that's there, and determining the economic value of it. Not only here, it is across health industries, especially from health industry. This is from Change Health, where they are trying to understand what is the economic value that they can drive, like what is the competition reference value to the what is our differentiator or the unique value delivery that's out there. Every customer would have their preference, right? Some would like to tap into Air France, some would like to tap into Emirates. It's also on the customer based, and of course the prices we see based on our experiences, it varies, and something is preferred, and this is also tapping into the customer willingness to pay. A customer might just be ready to pay 5K extra if they're getting better service, right? And how do we really then drive the total economic value out of it? And this is of course in collaboration with the customer, giving them a better product in place, and also doing a win and loss analysis. And there are so many other factors that really drives, like we can look into types of pricing, like of course this is the dynamic pricing. Then there are price skimming, like when we keep dropping our prices, what is that is happening, understanding that, making the machine learn about it, or the costs associated with it, right? So it was supposed to go in XYZ product, but it went in ABC product, so there is a deviation cost associated with it. Then how do we really price that particular product to recover from the loss? Or be it a psychological pricing, what we call about threshold pricing, what I was also tapping onto the customer willingness to pay. So what is that break point where the customer is no more going to be interested in that particular product? So there are so many other variables, or be it the value based pricing that we are just talking about here. There are so many other variables that we are looking into to build the pricing recommendation engine. And to add on some of the factors here on the value based pricing, right? Like it's selecting the price meter, what is that we want to achieve as a KPI object, which also was the key factor which Netflix, Amazon, Facebook, all three had to be crystal clear in mind before even stepping up to build the recommendation engine. How do we link the value to the metric, and utilize the price meter to build the revenue model, or optimizing the target and execution of the price structure that we want to build, or expand the perceived value? So how do we really cross sell, upsell, and the various factors that is associated with it, and considering a range of influencing factors, right? Here I have one more slide where I would like to know more from the audience that as a customer, would you really like dynamic pricing? Because this is a secret weapon that is getting used by many industries across, and I'm sure in the next decade it's going to be the norm, having a different price for every customer, and having more of this collaborative filtering methods influencing us, and the recommender systems influencing us through neural networks. So type in your views here in many.com, use the same code. You might just have one chance to vote here, yes or no. This is something that we really want to look into. And also what I would like to hear from the larger audience is, what are the algorithms would you choose to build a pricing recommendation model after hearing what the dynamic pricing system has in place? And also the major factors that we talked about, apart from the general ones that we already know about, right? That of course, how much volume we are moving, the market that we are looking at, and so on and so forth, with the normal variables that we are already aware about. So this is a word cloud, just in the same site, a different code. So fill in your opinions around the same, and let's hear out what are the algorithm that's coming in your mind. Would you really go for a collaborative item, or user, or how would you really tap into? And then last but not the least, in the interest of time, the advanced application discussion that we want to have, right? So here is something that I want to touch upon on how do we really look into this recommender system building up. And this is something where we are also observing, so far in the last 5 years, we did not even have great data science courses out there in the industry. And now we see, and talking to various directors of multiple deans and universities, we see that best of the best universities are coming up with great courses. And similarly, we are seeing that things are stepping up and leveling up on the AI front. And what do I mean here is, because there's no more going to be a machine learning in silo, or recommender system in silo, or a predictive model in silo. So this is an end-to-end system that can be built with only AI areas, where we need to have computer vision, we need to do natural language processing, we have to have evolutionary algorithms in place. It's my experiences have been the critical and the critical problems that we had to be designed and tweaked with our in-depth knowledge that we have, rather than going by the direct algorithms that we have, and you would find the codes and the links that I've mentioned earlier. With having the links, you can find out there what are the key algorithms that we generally use in any kind of recommendation algorithm. And of course the reasoning, right? What even Amazon is doing, the deep neural network, what are the reasonings that were really worked out for them in the entire decade. This is something, key factors or the fuzzy techniques is something that is personally a lot complex and something that needs a lot of collaboration across team to really make it happen. And of course the knowledge engineering, like how are we making systems talk, how are we making the teams talk, and not only as a people to people and as an individual team, but how do we really make the systems talk. And the entire holistic scenario is something that can be in a better advanced situation of using these recommendation systems, right? So with that, I would pause here to take any questions that you guys have. Thank you so much for your time.
Hi, Sukanya. Thank you for the great session. It was really informative. We have one question,
Yeah.
and I would encourage other viewers to also put up their questions or any doubts that they may have in the chat box. So the question that we have is, how can we attribute the increase to recommendation system? I think this is from the Netflix example that you gave. Like there could
Hmm.
be many other factors, right? But how can we
Hmm.
attribute the benefits to recommendation system?
Okay. So of course, it all depends upon the data that we are collecting. Right now, there are something that I would like to recommend is to go by a hybrid attribute. So something we need to take into consideration is a multidimensional information model. How are we forming the matrix associated with it? So the sparsity associated with it. What are the learning materials that's out there, or are we able to find some link on the genetics between, if we are looking into a user collaboration, or an item collaborations from this past history that's out there. So I would suggest that these are the factors that we need to look into, but there is also a lot of literature review around this, especially on the real e-commerce applications, given that it has been hypely used by Netflix, Amazon, right? And some of the news channels and online suppliers also. So that is where on the movies, music, news, commerce, and medicines, they are like developing this rapidly with this cluster based collaborative filtering or dimensionally reduction based collaborative filtering, or hotting graph theoretical collaborative filtering is something that also taps onto my mind. And also simple things that we have learned earlier, like the base and network recommendations and so on and so forth, like how do we really use those things. So yeah, I think we really need to drive up on how do we make the association, rule mining, and the pattern finding, which can really add up. And that's what I believe even Amazon and Netflix has done with all their searches into deep learning, and still not working for them, right? And they're going into the basic crux of neural network.
Cool, great. Another question that we have from Priya is, what are the techniques or methods to test recommendation engines? How can we compare various recommendation engines before deploying them?
Okay, so first, of course, we need to look into the KPIs that we are trying to solve, right? Some of the things like looking into the click rate ratios that we have as a KPI object on how the users are really clicking, if that is something that's there in the objective. So those are the initial factors I think should be getting started on the e-commerce platform. And then once we have the click rate ratios getting captured, are we increasing it over a time? How are we looking into the searches that the customers are making? Is that data tallying? And also the key factors of a recommendation engine, right? For example, simply if I take Amazon, we go to buy a mouse from Logitech, and it's also showing me other kind of products that's in place, or something else like a mouse pad along with it. So are customers really buying it? So how much is your sales would have happened without a recommendation engine to comparatively how your sales are happening with the recommendation engine in place. So that is the key factor to form out a graph and just look into it, is what I would suggest, apart from, of course, the RMSE factors and all that we check during the algorithm. But to have a real impact, I think those are the factors that we need to look into it.
And I assume that for the other part of the question, that how can we compare various recommendation algorithms as well, the same theory can apply, that we can probably compare how they're working, like the different algorithms are working.
Yeah, I think, of course, the input that we are feeding into any kind of recommendation algorithm, right, is going to be different. So, of course, in the hybrid, we are not going to leave out any kind of data, or the kind of, just if we want to go for a user-based or an item-based collaborative filtering, how is it working in silos? What are the factors improving it or the factors decreasing it? So, if we really want to do parallel checks, I would suggest to start off with a basic collaborative filtering in place, and then to work upon it. And to also, it differs a lot based on case to case. So for today, standing today, healthcare industry might not have enough data that they have collected in a proper format for a particular patient. And how would they really give any kind of a recommendation for a particular device that might just help them check things at home? But that might not be the case in the retail e-commerce industry, or be it in the airline industry, or so on and so forth, right? So it also depends the kind of data that we are collecting, where I had mentioned about the challenges. So how you really shape up the data, and then building from the scratch to a little deeper. And of course, if you really want to check and compare, so I would again suggest that we can have a lot of factors on looking into the probability of a customer clicking into it, but the key thing is whether it's actually happening or not. So it's always better to look into how would your system work, maybe without the recommendation system to with the recommendation system, or be it within different recommendation systems. So maybe for a period of 3 months, a quarter, you have used different recommendation system to compared to your last quarter, and how have your things differed. And that is one of the key factors that is what even Amazon is using today.
Yeah, that makes sense. Another question that we have is, how can we improve the accuracy of recommendation systems?
Okay. So this is a very broad topic, right? And to answer this particular question, I would say, of course, data is something that's going to help you. It also important, the kind of data that we are collecting, not only in the first degree, right? What are the kind of features that we are trying to generate? So improving accuracy does not really mean that things are going to work better on the outside world, but there are different kind of factors by which we can really influence technically on how do we really supercharge. For example, our recommended system today, I'm getting an accuracy of 50%, and still my recommendation system is working great, while it might just give me 90% in hand, and it might not just work, right? So I would say go by the standard similarity computational techniques that's already out there. Go by the boost your algorithm using the model size that is out there. And what else can I think of? Use your users, right, to drive your success. So what are the things that you can drive from the users? Or for example, I can think of Target, where they literally take up the item description that they have in their site, break that entirely up, do natural language processing, take the keywords out, and they have their categories as another variable, and they try to tap on that what are the things that a customer can buy on the similar section. So we just need to play around where they're just even trying to predict whether the customer is going to buy a banana or not from them, or what is the perishability of a particular banana that is entering their store. So it's going on to a different level, and we have to be a little innovative on all the methods that we are trying to use to get to a better accuracy.
Okay. Next, we have a number of questions into one. What should be the architecture for this? How should I proceed for data collection? What are the different features I can consider, and what algorithms might best suit the system?
Hmm. So I think this is basically the crux of the recommender system and how to go about on the techniques, right? So this is something that is already there in the slide as a link, and you guys can go through it. So it is not something I can broadly elaborate out here because
Mm-hmm.
you need to see it visually. The entire architecture is in place, and that's why I have shared those links in the slides.
Great. So we can
Earlier.
probably add that slide to the video description later on,
Correct.
and
Yeah.
yeah, learners can refer from there. Okay, so the last question that we have as of now is,
Hmm.
how did you make the transition from a triple E and MBA student to a data scientist?
Okay. So honestly, when we were doing engineering, there was not much of a. I'm not aware about others, but we didn't have much of a foresee of where we will really land up. But I never regret doing triple engineering. That was one of the toughest engineering sections, so as to say, and we learned a lot about the hard world and the soft world, right? Even there, we had software systems where we really need to make electronics work and systems work. It was a great learning. In fact, I started off with my career being with the BHL R&D division, where I worked in the AI robotics center. So you would be familiar and would have seen now a lot about the KUKA robots that's there, right? Like that's just like a hand, which really helps us to design a lot of things, and it's like rapidly getting used as a German robot across industries and across countries. So 10 11 years back, I was working at that particular robot and they had their own software languages. So you have to really design that particular robot to perform a particular task, and that was in dams you have turbines, and how do you really carve out that turbines and do the programming in that particular KUKA robot uh, to really remove this human interaction and humans going through this entire massive process of cutting those turbines, and many people have lost hands and there are chemicals that gets released. So that was a specific motive behind it. And even there, given that I had great mentors out there, the senior engineers, they guided me, and it was never different, right? And moving into the then of course BHL, right? And starting my career there, I learned a lot, and then slowly transitioning into this data world, because the data world really and we did not even have so much of hype or projects around data science at that point of time. But it gradually, I would honestly speak that it attracted me in some fashion, where we can really take out so much of features and so much of insights out of data, and how much we can influence on our daily revenue generation for a company, right? And it just started out of curiosity, and things turned out there. And of course, I had great professors from IIM Bangalore who have backed me up, who have helped me learn a lot with this data. So not only data, big data, all the hypes that we had like 2 3 years back, right? And there were a lot of collaboration from the industry that supported me. We did a lot of projects from college with the industry data that's out there. How do insurance looks into something? How does banking looks into influence their users through their Twitter data? Not that they disclosed all the data to us, but it's all interesting phases, and some of them being small projects also is going to help you develop your thinking power, and not necessarily always building up your domain knowledge, right? But of course, as getting associated with a domain on the longer run, I would say it helps a lot, because you get to learn the end-to-end business process that's associated with it, and that's where you can really make a return on investment impact in a company with all the knowledge that you have in data science.
Mhm.
Yeah.
That sounds very interesting. Um, so we also have the context to the earlier question. There was
Mm,
multiple questions that were asked in one. There was
mm,
actually, I have 20,000 plus sets of data science problems or courses.
mm,
I
mm,
want to build a recommendation engine on top of it. How shall I
mm,
approach this from scratch? Then there were the questions about architecture, or how should I proceed for data collection? What are the
mm.
different features I can consider, and what algorithms might best suit the system?
Hmm. Gunika, can you just repeat the first two sentences you mentioned? Is it a data
Yeah.
set of what?
Sets of 20,000 plus sets of data science problems or courses.
Hmm.
So probably just to recommend data science courses to
Hmm.
people, the person wants
Hmm.
to build a recommendation engine.
Hmm. Very good question and very innovative thinking. So this is something that I think already MIT is using it, and if you land up post, I think the COVID scenarios, you would see many of the colleges have also turned into Google Ads, who is trying to target. So basically, on the data science program, we need to do a segmentation first. On what are the data science courses actually offering particular users. So there will be various levels of users out there in the industry who really want. So first thing that we need to do is to think from a user perspective mind. And for example, what a person who is stepping onto the data science industry might look for. Maybe they are looking for a full-time 2-year course. They want proper in-depth study of all the topics that's out there, including AI, along with internship, and what are the factors influencing those kind of data science courses that's out there. Second being, of course, there are mid and senior level who have to keep up with the pace of where the world is running. They want to learn more about data sciences, and how do they really influence, or if they have to influence a particular team which is not directly working in data science, but knowing the crux and matters on how these things are going to influence them on running their particular business every day. So those are the kind of another set of users. And last but not the least, we are looking at the CX level, right? Where they are looking at a very high level, and they will be mostly interested on how do I get return on investment, or the investors that's out there, to know about more about these fields and what it has in store for us. So of course, segmentation is one. Don't go blindly with any kind of like dropping down into a collaborative filtering or hybrid filtering, so as to be, but mostly making it more user specific. How do you really segment the data out? How do you really pick up the kind of courses that all the industries are giving? I think there is a company called Emeritus or something. I'm not able to remember. I might mispronounce also, but they are really doing this stuff. They're just picking up all the data science courses that's available across colleges in the world, and whether it's online or whether it's a classroom study, those are the features that we need to look into, which might influence that whether you're gonna share this particular data science program across the world, whoever can log in online, or to a specific, like if we are looking into just Germany based, and there is a classroom based invitation to where 2 semesters needs to be completed. So these are the factors that needs to be taken into account, and also the financial aspect of the user. So of course, a very heavy course is something that an initial player might not be able to pay. So these are the factors that right now comes into mind. It's more of like feature engineering to get started with, and then of course segmentation, and then of course on the recommendation front, taking all these variables into pictures and going for a hybrid model. If you do not have the user specific data, right? If you are absolutely going to go for a new user and recommend something to them, and no data is something that you're able to collect from a new user whom you're not able, you do not have any data to collect, then I would just suggest you to go for item. So maybe something which is very much people in the vicinity or in the same zip code area is looking for, or people who are working in the same company is looking for through LinkedIn, and so on and so forth, if that helped.
Great. Yeah, that was very helpful. And I believe if we have a similar problem of maybe suggesting problems or questions, data science questions to people, then a similar approach will be followed.
Data science problem. So when data science problems are there, it can be because of various issues, right? It can be a deep down technical problem. It
No,
can
no.
be
I mean, as in problem statements, like the questions or datathons. Like,
hmm, hmm.
for example, in
Okay.
B5, we have datathons
Yeah,
conducted weekly that
yeah,
people
yeah,
attempt. So,
yeah.
supposedly, if you want to maybe suggest some of the
Hmm,
users that might
hmm,
want to participate in that particular problem, so what do you
hmm,
suggest for
hmm.
that?
Yeah, so for that, I think for this particular example, right, Gunika, if I just take it up, if I wants to suggest a particular
Mm-hmm.
datathon to a larger number of audience and then have a more click and turn up ratio, something of course we need to use the tags that we use, right? Like creating our own enablers and our own value system inside just how Facebook was doing it, like how people are reacting to it. So maybe taking in collaboration help with the marketing, taking in collaboration help with Google Ads, and getting better tags for that is something that we can use in addition to make a better reach, and then having a weighted average with all kind of reactions that's out there for a particular post that's out there, and calculating it and targeting certain users to widen the field.
Mm-hmm. Okay,
Yeah.
great.
Yeah.
Anwe asks, I'm good in Python. How to start with data science, how to solve problems on Kaggle, and how to learn machine learning.
Okay, very good question. So you are in an era where there is no less resource in the world. I have a list where it helps initial data science learners to get started with. I can share it with the team out here, and maybe they can pass on to you, or maybe keep it in the same folder of the PPT where everybody can have an access and go about. Because this is something that we created earlier, and then every now and then there are a lot of hackathons happening, and I'm getting requests for being a mentor. So there are also mentees who are trying to start their hands with a scratch. And of course these kind of forums like Women in Data Science, it is regardless of gender, and this is to support every kind of person who is trying to thrive on the data science field, right? So we have these kind of set handy, and I can definitely share with you, all of you, guide how to get started. But all in all, I would like to just mention one key point. Sometimes we, being from different world, get a little lost and find it a little difficult to start on the technical front. There is a lot of things, but what is important to understand is to have the logic correct, why we are doing it, what is needed to do it, and then how do we really do it. So I'm sure if we put some effort, nothing is hard to learn.
Yeah, absolutely.
Yeah.
And that
Yeah.
list will be very useful. Priya also asks if you can also share some materials along for the RNN-based recommendation systems.
Sorry,
That'll be
Kanika,
great.
can you
Uh,
come
Priya
with the
asks
question?
if
Yeah.
if you can share some material on RNN-based recommendation.
Sure, I'll take a note and I will definitely share. If I have some notebook of my own, which
Mhm.
I have tried on, I will share that. And if not, then I can recommend, some GitHub accounts, which it's good to follow and learn more from.
Yeah, definitely. I think we're almost done with the questions. So, as a final note, like, what advice would you like to give to all the learners out there from your experience in the
Uh,
past?
so yeah, so from my side, I would just like to speak. If I just have to give one word, right? I would say collaborate. So collaboration is the key, guys. Try to collaborate whatever you're trying to do, whichever level we are in. If we do things in silos, things might not work out. It might just not cross through any some kind of a design logic might just not pass through our mind. But with discussion, which with our hands-on experiences, is that's when we learn. So with my experience also with so much of that datathons around the world, and also being associated with bits for 4 5 years, right, interacting with so many new players in the data science field, it's just the collaboration that works. I have seen people struggling really hard and leaving it midway on the data science field just because they were trying things in silo, and things started getting just so difficult, because it's not only one subject that we are dealing out here. It needs a concrete understanding of the problem that we are having, a technical sound knowledge, what are we trying to solve, as well as mathematical background supporting the same, on how we can design it better or to make it a foolproof process, right, end to end with data engineers in place. So I mean, this is something that is extremely important, and I have seen other people who have teamed up better, who people who are taking courses together in data science in the same college, teaming up better to perform or get into a hackathon, giving their hands a try on learning and asking the basic questions, silly questions. And of course, there are so many of us, right, who are ready to help you guys anytime you need. So collaborate as much as possible, guys. That's my key message.
That's a really good advice. I think that collaboration does really help in every way. Like even if you're a beginner, you team up and try learn in groups. That's also a
Mm.
very helpful method to learn. And thank you so much, Sukanya. It was a really insightful session. Actually, we had a lot of interesting talk. You covered a lot of doubts of all the learners. And thank you to everyone who joined. For Anvay who asked about how to get started with machine learning, we also have a number of courses or boot camps that we conducted in the past on data science and on machine learning. We also have an ongoing data science boot camp going on. So any of you who is interested can join there. And Women in Data Science is a volunteer driven initiative. So, to raise awareness about the gender diversity, it was created. And more volunteers are welcome to join. So, as asked by Gaurav, does Women in Data Science not consider gender? No, everyone, including male and female, are welcome to join and be a part of it. So, thank you to everyone who joined the session. We had a great time. Hope you had a great time too. Thank you, Sukanya. And I think we can end the session for now. Bye bye.
Yeah. Thank you, everyone. Bye bye.